Hi, I'm going to show you one of the solution of a question which was asked in ENGI 9411 Probabilistic Methods in Engineering final exam here at Memorial University. This was based on Bayesian network, and here is our question. It is saying that for Bayesian network shown below, without using any software tool, find the probability of P1 given that x1 when x is instantiated. Find the probability of the Q1 given that P1 when P is instantiated, and find the probability of the W1 given that P1 when P is instantiated. Assume all nodes have binary states, so this means they will be in the states of 1 and 2. So this is the network which was given in the exam. For this probability, there were some instructions given to the student. I will assume some numerical values to solve it. Now the additional information was to use this relationship because we are not sure if y and z are independent or not. Again, for the w and q, we will use this joint probability relationship. So in today's video, I'm just going to solve this part A. Maybe in some other video I will work on the rest of the two parts. That's what is our objective for today's video. This was my network here. I'm going to assume some values for these. Let's say I assume this value, probability of the Q1 over Z1 as 0.75. Every student will have their own values based on their student number. And this value, probability of the Q1, given that Z2, that I'm going to assume as 0.775. Now, what is my objective here? My objective is to find out the probability that P1 given that x1. That's what I want to find out. So I'm going to start with the law of total probability, which says that in order to find the probability of P1, we need to look for the parents. And we'll go back to our network here. Now in the network, we have the probability of the P. P has the parents of W and Q. Now in this solution, I'm going to instantiate X. So this one should be highlighted here. So P has the parents of W and the Q. So it will be the probability of W1 Q1 times the probability of P1 given that the W1, these ones, and Q1. Now the second combination could be the probability of W1 into Q2 times the probability of P1 given that W1 and Q2. The third combination could be the probability of W2 and Q1. This should be multiplied by the probability of the P1 given that W2 and Q1, and plus the last combination could be the probability of W2, Q2, and probability of P1 given that W2 and Q2. So that is using the law of total probability. Now, to simplify this, we know two relationships here. When we have y and z, the joint probability relationship is given here. When we have w and q, we have the relationship given here. So that's what this is what I'm going to use here. So the next step will be my probability of P1, that should be equals to. This is the probability of the W1 and the Q1. According to this relationship, that should turns out to be probability of W1 multiplied by the probability of, this is Q over W. So the Q is Q1, that should be Q1 over the W is the W1 here. And then I have this relationship coming as such. Probability of the P1 given that W1 and Q1 plus. Similarly, for the second one, we have W1 and Q2 relationship. So that should be equals to probability of W1 times the probability of Q2 this time, given that W1 multiplied by the probability of this one is the P1, given that W1 and Q2 plus. Now in the third state, we have W2 and the Q is Q1. By using this same relationship, we will have the probability of W2 times the probability of, now it will be Q1 this time, given that W2 multiplied by the probability of P1, given that it will be W2 and Q1. Now in the last one, we have the relationships between W2 and the Q2. So the last one term should be P of W2 times P of probability of Q2 divided by W2 multiplied by the last term. We have P1 here, given that W2 and Q2. This is the simplification of the law of total probability when I applied that on P1 in the network. Now in the next step, I need to take its conditional relationship with the x1, that is what is being asked in the question. So I'm going on the next slide here. Now what is my objective here? This relationship, the left hand side, which is P1, that should be find out in terms of x1. So what I'm going to do, I will take the conditional relationship of each and every terms here with respect to x1. So this W1 will become W1 given that x1. Similarly, this will be Q1 given that W1 and x1. And the third term will be P1 given that W1, Q1 and x1. So this will be P of W1 given that x1 multiplied by the P of Q1 given that W1 and x1. The last term should be probability of, this is the P1 given that, now we should have it W1 here, Q1 here and x1 here plus. Now the same procedure, let me go back here, same procedure will be applied on the second term here, third term and fourth term. So So let me write down for the second term here now, plus probability of that was based on W1 given that X1 times the probability of, this time it was with Q2, given that W1 and X1 times the probability of P1 given that W1 and Q2 and X1 plus, on the third term, if you allow me to go back here, it is with respect to W2 and this one Q1 given that W2. So this term should be probability of W2 given that X1 times the probability of Q1 given that W2 and X1 times the last term will be probability of P1 given that it will be W2 and Q1 and X1 plus the last term here, if you allow me to go back, is with respect to W2 and Q2. This should be your probability of W2 given that X1 times probability of Q2 given that W2 and X1 times the probability of P1 given that W2, Q2 and X1. So far we have just taken the conditional relationships in our law of total probability. In the next step, I will apply the Markovian condition here. So the next step will be to find out the, of course, the left hand side remains the same so far. P1 given that X1, that's what is the left hand side here. So that will be equals to. For the Markovian conditions, we will go back to our network here. Now W as immediate parent of the Y. So this term, the very first term, I can't simplify it. So I will write it down as such according to the Markovian condition. So this will be W1 given that X1 times. In the next term, we will look on the parents of the Q here. In the network, the parent of the Q is only Z. It is not W and X. So I will have to write this equation as such. It will be Q1, W1 and X1 times the probability of. Now in the last term, the P is what we are concerned with. The P has the parents of W and Q. So this means in this equation, I can simply ignore the X1 according to the Markovian conditions. So this will be probability of the P1 given that W1 and Q1. Again, why I am not writing X1 here? Because X is not the immediate parent of P in the network. Plus, the same thing applies on the second term. It will be turns out to be W1 over X1. The structure of the network does not change when you apply the Markovian condition. probability of Q2 given that W1 and X1 times the probability of P1 given that now in this one we will have the W1 and Q2 plus the same rule applies on the third term. It will be probability of it is W2 over X1, W2 over X1, and then the probability of Q1 given that W2 X1 times the probability of, now again in this term we can ignore our X1 because X is not the immediate parent of P. This will be the P1 given that W2 and Q1. And the last term should be this one here. It is the probability of W2 given that X1 times the probability of Q2 given that W2 and X1, and according to the Markovian condition this term X1 can be neglected here, so it will be P1 given that W2 and Q2. This is what so far we applied our Markovian conditions here. In the next step I need to find out these terms here, probability of W1 given that X1 and the rest of the terms related to this. For that one I will again use the law of total probability. So what I'm going to find now, I need to find out my probability of W1 given that X1. That's what I need to find out. Again using the law of total probability, I can write it down that P of W1 is equals to, I will go back to my network here. The W has a parent of Y and Z, so it will be the joint probability, just like we were doing before. It will be probability of Y1 and Z1 into the probability of W1, Y1 and Z1 plus it will be the joint probability of Y1 and Z2 probability of W1 given that Y1 and Z2. The third term should be probability of the combination of Y2 and Z1 times the probability of W1 given that we have the Y2 and Z1 plus the last combination will be Y2 and Z2. So this will be the probability of Y2 and Z2, the joint probability between Y and Z multiplied by the probability of W1 Y2 and Z2. So make it this is Y1. So that is coming from the law of total probability. Now if you recall the relationship again, this was the relationship, that's what I'm going to use now. It is the joint probability relationship between Y and Z. That's what I need to apply on these relationships. This one this one and this one. So my probability of W1, that will be equals to, now the relationship between Y and Z, it will give you the probability of Y1 times the probability of Z1 given that Y1 times the probability of W1 given that Y1 and Z1 is Y1 and Z1 plus this relationship, the second term, which is the probability of, now this time again it is Y1 times the probability of Z2 given that Y1 times the probability of, this is W1 here, given that Y1 and Z2 plus the third term is the Y2 and Z1. This will be the probability of Y2 and Z1 given that Y2 times the probability of W1 into Z1 plus the last term is between Y2 and Z2. So this one will be the probability of Y2 into the probability of Z2 given that Y2 and the probability of this term here W1 given that Y2 and Z2. In the next step, as I am looking for, I need to take the conditional probability with respect to x1. So this term on the left hand side should be W1 given that x1. Now just like I was doing before, I will take the conditional probability of y1 with respect to x1, z1 given that y1 and x1, the probability of w1 given that y1, z1 and x1. This is what I am going to do on the next slide. So my probability of the w1 given that x1, I can write it down again here. I am looking to find out w1 given that x1 is equals to. Now I will explain in the first term the same procedure as we were doing before. This is the probability of the y1 given that x1. This will be the probability of y1 given that x1 times the second term will be probability of the z1 given that y1 and x1, this term here. So that will be the probability of z1 given that y1 and x1 times the probability of, now this last term here, it will be w1 given that y1, z1 and x1. So that should be w1 given that y1, z1 and x1 plus the second term here is with respect to y1 and z2 given that y1. So we will have this as probability of y1, the same procedure that we were doing before, x1 times the probability of this is the z2 here given that y1 and x1 times the probability of, now the last term here, it is probability of w1 given that y1 and z2, and we will take the x1 as well. this one will be W1 given that Y1, Z2 and X1 plus the third term here is with respect to Y2. So it will be Y2 given that X1. It will be the probability of Y2 given that X1 times the probability of, now this one will be Z1 given that Y2 and X1. So this will be the probability of Z1 given that Y2 and X1. And then we have the last term here, which will be W1 given that Y2, Z1 and X1. It will be W1 given that Y2, Z1 and X1 plus the last term will be probability of, this will be Y2 given that X1, probability of Y2 given that X1 now the second term is here Z2 given that Y2, it should be taken as Z2 given that Y2 and X1. So that will be Z2 given that Y2 and X1 and the probability of W1 given that Y2, Z2, this is the comma here, and X1. Now in the next step, I will apply the Markovian condition and will simplify these relationships. So on the left hand side, I have the probability of W1 given that X1. Same rule as we were using before, the Markovian conditions, Y1 and X1. We go back to our network here and we see that this is the Y1 and X is the parent here. That should be written as probability of Y1 given that X1 into the probability of the Z here. Let's go back to network here. Z has the parent of X only, so we can ignore the Y into that because Y is not the parent of Z in the network. So for this relationship here, we can ignore our Y because Y is not the parent of Z. So I can write it down that it will be the probability of Z1 given that X1. Probability of W1. Again, we will go back to our network and see the parents of W here. So the W has the parent of Y and Z only, not X. X is not the immediate parent of W. So we can ignore this X here when we are applying the Markovian condition. This was the basic idea to be used in this question. Plus the same Markovian condition apply in the second term. So we will have the probability of Y1 given that X1 times the probability of, now in this term again I can ignore my X here, my Y here because Z has the parent of X, not Y. So I can write it down as Z2 given that my X1 because Y is not the parent of Z, so I can ignore that. Assume this network. and the same rule apply on the last term, which will be W1 given that it will be Y1 and Z2 plus this term here, probability of Y2 given that X1 times, in this term we can ignore Y using the Markov condition, so it will be Z1 given that X1 times the probability of W1 given that here I can ignore X again, so this will be the Y2 and Z1 plus the last term should be the P of this is Y2 given that X1 times the probability of Z2 given that X1 and this term should be probability of W1 given that it will be the Y2 and Z2. So X1 we can neglect using the Markov condition. In the next step, we just need to plug in our values. So I will go on the next slide here. So the probability of W1 given that X1 is equals to, the first term is Y1, the probability of the Y1 given that X1. We go back to our network. So this value is 0.1. This should be 0.1 multiplied by, we need the probability of the Z1 given that X1. We go back to our network again. So we need the probability of Z1 given that X1, which is 0.2 here, multiplied by 0.2 multiplied by the last term is the probability of W1 given that Y1 and Z1. So I go back to my network here. So this is the value, which is 0.2 again. The probability of the W1 given that Y1 and Z1. This is given to you as 0.2 multiplied by 0.2. Now I'm going to plug in the values directly. It will be 0.1 multiplied by 0.8 multiplied by 0.3 plus 0.9 multiplied by 0.2 multiplied by 0.5. All these values are coming from the question, plus 0.9 times 0.8 multiplied by 0.8. So once you solve it, you will get the answer of 0.692. And if I wish to find out my second state, because this is a binary state here, which is W2 given that X1, so that should be equals to 1 minus 0.692, and that turns out to be 0.306. I'm going back to my very original work here for the P1 given that X1. So these things we have found out. These terms are, we have calculated all of them. Now we need to have this term here. Again I will use the law of total probability for Q1, and I will take the conditional probabilities with respect to W1 and X1. What is my objective now? I want to find out the probability of Q1 given that W1 and X1. So I will start by the law of total probability, which says that the probability of Q1 that is equals to, we will go to the network here. So this is my Q. So Z is the only parent of the Q, and these are in the binary state. So I will take the two states of Z here. So that will be equal to my probability of Z1 into the probability of Q1. This is the law of total probability that I am applying here, plus the probability of Z2 multiplied by the probability of Q1 given that Z2. Now I need to find out its conditional probability with respect to W1 and X1. So on the left hand side I will have the probability of Q1 given that W1 and X1. Now the same thing applies for each and every term on the right hand side. So this term will become the probability of Z1 given that W1 and X1 multiplied by the probability of, this term will become the Q1 over Z1 is already available there. So it will be Z1. We need to introduce W1 and X1. W1 and X1 plus this term will be probability of Z2 with respect to W1 and X1 times the last term will be probability of Q1 given that Z2 is already available. The new terms will be W1 and X1. It will be W1 and X1. Now I'm going to apply the Markovian condition here again. So this one will be, when we look on the network here, so Z is supposed to have a relationship with W1 and X1. When we go on the network, we see that only X is the immediate parent of Z. So we can ignore the W out of this. So this relationship we can simplify as the probability of Z1 given that according to the Markovian conditions, I can write it down as X1 multiplied by probability of, we will look on the parent of the Q here in the network. So the Q parents is only Z here. So that means in this term I can ignore my W1 and X1. Why? Because Z is the only parent of Q. So this term will reduce to my Q1 given that Z1 plus the same rules applies on the second term. It will be Z2 given that my X1 here and the probability of Q. The only parent Q has is the Z only. So only Z2 term will stay, the rest of them will be eliminated. Probability of the Z1 given that X1, I will go to network here. This is my Z1 given that X1, 0.2. So let's write it down here. This is the 0.2 multiplied by, the next term is the probability of the Q1 given that Z1. The probability of the Q1 given that Z1, as I said, I am assuming it is as 0.75. So it will be 0.75 plus this is Z2 over X1. So this means it will be 1 minus the Z1 given that X1, which is 0.2. 1 minus 0.2 multiplied by the probability of the Q1 given that Z2. Let's go on the network here. So the Q1 over given that Z2, I am assuming this is value as 0.775. So So once you solve it, you will get the answer of 0.77. So my values of probability of the Q1, given that W1 and X1 is 0.77, if I want to find the second state value, I can just subtract it from 1. By that I mean to say, I know the values of probability of Q1, given that W1 and X1, that is equals to, we just find out is 0.77. If I want to find out the second state, because it is a binary state system, it will be Q2, given that W1 and X1. That is equals to 1 minus 0.77, which is 0.23. If we go back to our network here, so I have these calculated. I wish to find out, this one is also calculated. I wish to find out now this term here, Q1, given that W2 and X1. So I will do the same procedure, the law of total probability, and take the conditional probability with respect to W2 and X1. So what is our objective now? We want to find out the probability of Q1, given that W2 and X1. That's what we need to find out. Now, using the law of total probability, probability of the Q1 will be equals to, the Q has the parents of only Z is a parent. So we'll take the binary states of the Z. So that will be equals to the probability of Z1, the first state of the Z, times the probability of the Q1, given that Z1, plus the probability of Z2 into the probability of Q1 over the Z2. Now we need to find out them respect to the, this is the probability. We need to find out respect to Q1, given that W2 and X1. And the same conditional probabilities should be applied on the right hand side. So that one will be equals to the probability of Z1, given that W2 and X1, times the probability of, this is my Q1, given that Z1 and W2 and X1, plus this is the P of probability of Z2, so that should be equals to the probability of Z2, given that the W1 and X1, W2 and X1, that is W2 and X1. So the last term should be probability of the Q1, given that Z2 and W2 and X1. Now the next step is the same. I will apply the Markovian condition here. So that will be equals to, let's go back to network and see what are the parents of Z here. So the Z has a parent of X only. This means I can ignore my W. So this term, using the Markovian condition, I can write it down as probability of Z1, given that X1, because X is the parent of Z, times the probability of Q1. Now we will see what are the parents of the Q in the network. So the Q has the only parent of Z here. So I can ignore my W2 and X1. So that will be equals to Q1 over Z1 plus probability of, again this term, we can ignore the W because W is not the parent of Z. So that should be Z2 given that x1 into the probability of q1 given that z2. Now the next is we just plug in our values here. Probability of the z1 given that x1. Let's go back to the network here. So probability of the z1 given that x1 is 0.2. Multiplied by probability of the q1 given that z1. So the q1 given that z1 is 0.75, which is 0.75 plus this term will be 1 minus 0.2 times the probability of the q1 given that z2 from the network again. This is 0.775. Once you solve it, you will get the answer of 0.77. And if I want to calculate the Q2 given that W2 and X1, I just need to subtract 1 out of this. So by that I mean to say the probability of your Q2 given that W2 and X1, that should be equals to 1 minus 0.77, that turns out to be 0.3. Now I will go back to my very original relationship which I developed. So all these terms here have been found out. Now this relationship is given into the network, and now I'm going to plug in the values for this. So I can find out now the probability of the P1 given that X1. So the probability of P1 given that X1, that is equals to, so let's start from here. I need to have the probability of the W1 given that X1. So the probability of W1 given that X1 is 0.692. So this is 0.692 multiplied by what I need the next term. The next term is probability of the Q1 given that W1 and X1, which we just find out as 0.77. It will be 0.77 multiplied by, now the last term here is the probability of the P1 given that Q1 and W1. Now this one is coming from the network. So I go back to my network here. The probability of the P1 given that W1 and Q1 is 0.3. 0.3. Now similarly, I'm going to write down the values for the next terms. You can see how we calculated them. So it is 0.962 multiplied by 0.23 multiplied by 0.1 plus 0.306 multiplied by 0.77 multiplied by 0.8 plus, let me explain you the last term. So the last term is I need the W2 given that X1. This one we calculated here, W2 given that X1, which is 0.306. 0.306. Now let's go to the main equation and see what we need here. And we need Q2 given that W2 and X1. Q2 given that W2 and X1. W2 and X1. So this is 0.3 multiplied by, the last term here is asking us for this term P1 given that W2 and Q2. For this one we go back to our question. So P1 given that W2 and Q2 is 0.3. Multiplied by 0.3. So once you solve this, you will get a value of 0.3853, or I can say that this is the 39%, and this is your final answer. It was not asked in the examination, but I can show you how you find it using the Genie software. How can I confirm this answer using the Genie software? Now this is my network here. So I have set up this network into the Genie. If you don't know how to use the Genie for the Bayesian network analysis, I will leave a link on the description so you can go through this. This is the network which I developed using the given information in the question statement. So what I need to do, I will just run my simulation and see what are the different probabilistic values associated with it. Now because I am concerned with the instantiation of the x, so I just instantiate my x1 here and then update my network, and the final value of the probability of the p given p1 given that x1, this is here Genie software is showing it is 39%. This is what we also calculated using our solution here. As you can see, this is 39%, and the Genie software is also giving you the same answer here, which is 39%. So this confirms that your all calculations are correct. I hope this helps. Thank you.